Test, mic check, 1, 2, 3, test. Okay, integrated math, and this is lesson 1.04. This is a continuation of the solutions video. So the first 16 questions are up. I did skip a couple, however, I believe it was 14 and 15 that I did not do, and you do not have to do those. So we're going to go ahead and continue with number 17 here. So it says on the Wechsler Adult Intelligence Scale, an average IQ is 100 with a standard deviation of 15. IQ scores between 90 and 109 are considered average. The question is, assuming IQ scores follow a normal distribution, what percent of people are considered average? Okay, so we want to find out. Let's go ahead and draw a normal distribution of that. And in the middle we have 100. And one standard deviation away is 115. That's 100 plus 15. Okay, one standard deviation, two standard deviations, and three. Going backwards, it's minus 15. And there's minus 1, minus 2, minus 3 standard deviations. So we're looking for the problems we've done up until now. They were always asking us about a very specific number, integer number of standard deviations. So from, say, 85 to 115. That would be easy. We know how to do that now. That's 68%, 95%, and 99.7%. Or in some of the questions we called it 100. But now they're throwing us some that are going to be in between. So 90 is going to be right here. So I'm going to draw that as somewhat of a heavy line. That's 90. And 109 is going to be right about here. I'm going to draw that as a heavy line, and that's 109. So we're looking for the people that are in this range right here, in between 90 and 109. So the first thing we do is find the z-score for 90 and 109. So let's go ahead and do that. Okay, let me go ahead and write the formula for it. Okay, so there's x, that's the value we're interested in, 90. There's 100, that's the mean, and there's the standard deviation, 15. All right, you do that and you get this. Just do that on your calculator, 10 divided by 15, and a negative sign means it's below the mean. Okay, do the same thing now for 109. Okay, so this is the z-score for 109, so it's going to range between those two z-scores. If that's what they were asking us, we'd have the answer. We could just actually do a subtraction. This would be 0.6. To find the difference between two numbers, you subtract. So if that's what we were looking for, it would be 0.6 minus negative 0.67. You'd effectively be adding, because you want to know the whole distance here. So there's 0.6, there's 0.67. So you add those two together, you get 1.27, and that's how many standard deviations between those two. But they're not asking that. They're asking for a percent. So we're going to have to go either to a table in the back of a book, and there are conversions if you have a statistics book like the one they use in AP Statistics, or you go to a calculator. So I'm going to bring up the calculator here. And there it is. Let me see if I can adjust this a little. Okay. So you're seeing it a little more clearly now. It's calculator.net, z-score calculator, and there's some numbers up there. You can see I've already done this. I'm going to clear it. So we're going to start with that. Okay, and the raw score, we're first going to start with 90. So we do 90. The mean is 100. And the standard deviation is 15. When I calculate that, it gives me a lot of numbers up here, but here's the three that are of most interest. And then what I really like about this particular online calculator is it shows you a graph and shows you it shades in the area that it's talking about. So it's telling us 90 in relation to 100. And it's telling us if we want to know what percent or what probability is of x being less than 90, it's everything that's in the red over on this side. And that is 0.252. We'll forget about all these extra digits here. And convert that to a percent, it's 25%. I'm going to show you how to do that. But right now it's 0.252. If down here it's x is greater than 90, so it's everything in this red shaded area to the right. And that's 0.747 or 0.8, and that would be 74.8. I'm rounding the 7 up. 74.8%. If you add these two probabilities together, you get 1. If you were to add those two numbers together, you get 1. Or the two percentages I said, 25.2% plus 74.8%, that would equal 100%. And you'll notice that if you put these two shaded areas together, these two graphs right here, the top two, they'll cover up the entire curve. So that would be 100%. The one we're interested in for this particular question, though, is the one on the bottom. It's just the area between 90 and 100. And that's going to be 0.248. Again, I'm rounding the 7 up. Okay, so I am going to go back. Okay, and so what that was this area right here that I'm shading in heavily now. That's that area. It's between 90 and 100. So I'm going to come down here, and that is 0.248. All right, now we'll go back to the calculator, and we're going to come down here, and we don't need to clear it. We just need to change the 90 to 109. We want to know the same thing about 109 in relation to 100 with a standard deviation of 50. And there you see it's a little over to the right side of the graph. Again, you have 0.726 there and 0.274 there. If you add those together, you get 1. Or that would be 72.6%. This would be 27.4%. If you add those two together, you get 100%. And again, you can see that these two on the top, these top two graphs, the red would cover, if you put them together, the red will cover the entire curve. But again, we're not interested in those right now. We're interested in this one, between 100 and 109. And we see that that's 0.22, and I'm going to round the 5 up to a 6, so 0.226. So now I'm going to go back to the camera. And that's going to be over here, 0.226. And if you add those two together, and that's, let me go ahead and, that's what I'm putting heavy lines like that. Okay, so this is the 109, this is the 90 to 100, this is 100 to 109. So if I add these two together, I'm going to get 0.474. Now to convert to a percentage, I'll just give you the little trick. We're going to talk about percentages and how to actually do them, but just to understand the little trick. To get it into a percentage, you take this decimal and you move it 2 places to the right. So it's between the 7 and the 4, between 7 and the other 4, right here. So that would give you, in percent, 47.4%. So a little bit less than 50%, or half of the people are in that range. Okay, so that's how, if you need to know not just a z-score, but a percent, you have to, as I say, either have a table in a book, that's just a big, long columns and columns and columns of numbers that you match up to the z-score, or you have a calculator, which is much easier, the one that we just used, okay? A link to that calculator is inside the lesson 1.04. All right, let's keep going. There's one more like this, and then I don't believe there are any more in this assignment that I can remember. Okay, so one measure of genius is an IQ score of above 135. What percent of people are considered genius? So real quickly, our X is 135, It's the value we're interested in. Mu, the mean, is 100. And sigma, standard deviation, is 15. Okay, this question's actually not that much to it, so I'm going to quickly just sketch a normal distribution. 135 is way up here. We said that 145 was 3 standard deviations and 130 was 2, so it's kind of a little bit past 2 standard deviations. This is 135. Anyway, we don't need to do a lot here. All we need to do is find what percent is above here, is over here. It's, in other words, in this little area down here underneath the curve. Now, if I were going to calculate z-score, I could do that, but I don't need to with that calculator. It'll just straight up give me the percentage. So I'm going to go back to the calculator, and I'm going to go down here, and I'm going to change this to 135. We're using the same mean and the same standard deviation, so I'm going to just put in 135 for my variable of interest, x. I'm going to click on that. Okay, and here's everybody. This big red area is everybody below 135. That's most people. This little area is everybody above 135. That's what we want. This area is what we used last time. It's between 100, between the mean and 135. But the second one this time is the one we're interested in. How many people, what percent are above that? And we can see it's a very small number. X is greater than 135. It's 0.0098. So I'll go back to my camera. So it's going to be that. This is called the probability. It's out of 1, but it's asking us for percentage. So the way you do it again is you move this over 2 places to there, and you get 0.98%. So less than 1% of the people. 1.00 would have been 1% of the people. This is less than 1% of the people have an IQ above 1.35. Okay, I think that's the only two that are asking for percentage, but at least you know where that is. And again, that link is in the Canvas site. Let's keep moving here. Einstein had an IQ score of 160. What is his z-score? So we're just figuring out the z-score. If that's x equals 160, mu equals 100, and sigma equals 15. Again, if you're doing this on line paper, you don't have to copy the question. Just be sure you clearly give the question number and the assignment 1.04. That should be at the top of each page very clearly. And then that all you have to write is what I'm actually writing down here. I would like you to draw a little normal graph, just sketch one, just so you know what we're talking about. So here's 160 way up here. And what we want is that little area right there, okay? Pretty much similar to the last problem, except there's going to be a lot fewer people. Okay, so his z-score is so his IQ is 4 standard deviations above the mean. Let's just go and see what percent of people have that IQ. So we're going to go back to our calculator. It didn't ask for this, but now that you know how to use it, it's really easy to use. So 160, same mean and same standard deviation. And what's above that? This is the probability of being above that. And you move the decimal over 2 places and you have this. So it's really, that's the percent above that. That's a fraction of a percent. Very small number of people have an IQ that high. Okay. And the next question, let's go back to our camera. Okay, well, I didn't read ahead on this one. What is the probability of an individual having a higher IQ than Einstein? It's this number, okay? So that would be probability. So you have 3 things. You have z-score, you have probability, and then you have percent. You have to use the calculator to get from z-score to probability, and then probability of percent, you just have to know how to convert, move the decimal over 2 places. So it's that number that I had up there initially that I got off the calculator. That's the probability right there, okay? That number, that. All right, let's keep going. All right, the average resting heart rate of a young adult is approximately 70 beats per minute. So that's going to be the mean with a standard deviation of 10. Okay, assume normal distribution. Again, they always have to assume a normal distribution here. Draw and label the normal curve that describes this distribution. Label the points for 55 and 80 beats per minute. And I'm reading down here. And shade in the area that represents the percent of people with heartbeats between 55 and 80 beats per minute. Okay, so let's go ahead and do that. And you don't have to draw a really big sketch. Just be sure there's enough space so you can write your numbers. And so the mean is 70. So one standard deviation is going to be 70 plus 10 is 80. Two standard deviations is 70, 10 plus, which is 90. And 3 is 100. Going down is 60. And then 50 for 2 standard deviations and 40 for 1 standard deviation. Okay. And let's see, so the points for 55 to 80. So they want to know, I'll draw these as heavy lines. That's right in between 50 and 60 is going to be 55. So there's that. And 80 is going to be that. So this is 55. And this is 80. Okay, so they want to know what's in between these. I'll shade it lightly. All right. So we did that. We've done A and B up here. Shade the area that represents the percent of people with heartbeats between 55. So there we did. We shaded that lightly here. And what percent of people have heartbeats between 55 and 80? So now we have to actually do the calculation. Again, because of the calculator, we don't need to do the z-score for this. They just want to know percent. They didn't ask z-score. Okay, so we're going to go straight over there, and we're going to have to change some of our numbers there. So we're going to clear, and what we're going to put in for the raw score, we're going to start with 55. That's the first of the two. The mean, it said, was 70, and the standard deviation, it said, was 10. And I'm going to click on calculate. Okay, and there you see this is everything below 55. This is everything above 55. So those top two added together are 100%. But again, this is like the very first question we just did. It wants to know between 55 and 70. So we're going to have to do this in two parts. So between 55 and 70 is 0.3. 0.433. Okay, and that's this right here. It's this area right here between 55 and 70. Okay, and now the next one we're going to do is going to be this one. And I'll just draw that as some heavy lines like that. That's between 70 and 80. So we're going to go back down. Whoops, you didn't see that. Sorry. I will get you that. Okay. And 80, here's 80. Okay. And what you can see on the screen now is this area over here is between 70 and 80. The bottom one, again, and that's 0.341. Okay, so now I'm going to go back to the camera and you'll see what I was talking about. So the first one between 55 and 70 is this, where I colored it in basically between 55 and 70. And between 70 and 80 is this number. And that was the one I did a thatch like that. So that'll give us the total there. So we add those two together. And that's going to be 0.774. Okay, and that's the probability. And then the percentage, we're going to move the decimal over 2 places, and that will give you 77.4%. So about 3/4 of the people have heartbeats in that kind of middle range right there, near 70, near the mean, okay? All right, next. The resting heart rate above 80 beats per minute is considered unhealthy. What percent of people have an unhealthy heart rate? Okay, well that should be already set up for us to do it. That's going to be, I'm going to just put little X's here. Everything to the right of the 80 line. Okay, so everything over in this area here to the right of the 80, that's unhealthy. So we'll go back to the calculator, and we are already set up for 80, but we want to look at a different graph this time. This time we want to look at this middle graph, the one that is where the red is to the right of 80. That's heartbeat greater than 80, and that's 0.159 if I round it up. So it's 0.159, and if we move the decimal over, we get 15.9%. Okay, so that right there, that's the number we're looking for. 0.159 is the probability. 15.9% is that they're to the right of 80. That's greater than 80. So I'll go back to my camera and I'll show you. I just wrote that right there. So you can just write that as a sentence, that 15.9% of people have unhealthy heartbeats. Don't write big, long explanations, but just enough that you're relating the numbers to the question, that it's not just numbers, it's answering a question. Okay, there's the explanation. Okay, all right, let's keep going. Okay, order the following from lowest to highest z-scores. Okay, we've already done this before. Let's just do it real quick. I'm just going to do it silently, and you can just watch and check your answer. Try to do it yourself. Don't just copy. And then I'm going to do it silently, and you can check your answer. So again, always write the formula first. Oh, this is the one we actually did in the instructional video, but I'll do it again. Why not? Oh no, it looks like the numbers are a little bit different. They might be, I don't know. Anyway, here we go. Okay, yeah, it looks like a couple of them were the same as the one done in the instructional. And there it is, the one with the highest number. 0.6 is greater than either of these two, so that's the greatest number of standard deviations above the mean. So that would be the highest z-score. Okay, a pharmaceutical company wants to test a new cholesterol drug. The average cholesterol of the target population is 200 milligrams, and they have a standard deviation of 25. Let's just go ahead and write down that data as we read it. 200 milligrams, standard deviation, 25. The company wished to test a sample of people that fall between 0.15 and 3 z-scores above the mean. Into what range must candidate's cholesterol level be in order for the candidate to be included in that study? Okay, so this one you're going to have to do a little algebra on. They're giving you the z-score, and they want you to find the number that produces that z-score. So let's draw the diagram. So mean is 200. One standard deviation. Okay, there's 1, 2, 3 standard deviations. Okay, but what they want to know is between 1.5 and 3 z-scores. So here's 1, here's 2, so 1.5 is right here. I'm actually draw this up on the top. And 3 is going to be right here, 3 standard deviations. So this is 1.5. and this is 3.0. Okay, so we're going to use the formula. Okay, now we know this, and we know this. We're trying to find this. I generally tell students do the algebra first, and then come back and do the plug in the numbers. The reason is because you can use the same formula for both parts of this question. So rather than plugging in the numbers right away and solving, let's do the algebra first. So we need to isolate x. We're trying to find out what x is, what that number is, that cholesterol number is. So we need to make this go away and this go away. We need to isolate that. So whenever you have a situation like this, x minus mu over sigma or something minus something or plus something, you always get rid of the denominator first. So what I'm going to do first is I'm going to come over here and just rewrite it. So there's two steps to this. Multiply both sides by sigma. These cancel. And then what you have down here is sigma times z equals x minus mu. Okay? Now you need to get x by itself. You have to get rid of this. Now that last one was a multiply divide operation. This is a subtract add operation. You're doing the inverse. You're trying to reverse the number. So I have a negative mu. I get rid of it by adding mu. That means I have to add mu over on this side. Minus mu plus mu goes away. Now I'm going to put the x over on the left-hand side and put this stuff over on the right side. That's just kind of reversing everything around the equal sign. Generally, you want your solve for variable to be on the left. So I'm going to put x over here equals. Now what I have is mu times z plus, sigma, I said that wrong. Sigma times z plus mu. Okay, and there's the formula. So whatever sigma is, I'm going to multiply that by the z number, and then I'm going to add mu. So let's go up here. I don't know if I can fit all this on one page, but I'm going to do the 1.5 here. We needed to do 1.5 and 3. Those were the two we were given right here. 1.5 and 3 for z. Okay, so that means that the value, the cholesterol value, is going to equal 25 is the standard deviation sigma times the z-score. The first one we're going to do is 1.5. That's going to be plus mu, which is 200. So x, that first cholesterol score, 25 times 1.5 is 37.5, plus 200 is 237.5 milligrams of cholesterol. Now I'll go down and I'll do the 3.0. So I have x. 25 times 3 is 75, plus 200 is 275. So to be in the range they were interested in, they would have to be, I'm just going to abbreviate it down here, they would have to be between 237.5 and 275. Milligrams of cholesterol. So there's your answer right there. Get it a little higher on the screen. 275. Okay? All right, let's keep going. Okie doke. Highly selective university will only admit students who place at least two z-scores above the mean on the ACT. It has a mean of 20.8. So let's go ahead and write that down. Mean equals 20.8. And a standard deviation of 5.6. What is the minimum score that an applicant must obtain to be admitted to the university? Okay, so they have to be 2 z-scores above, and that's all we really have to find out. So the minimum score is whatever 2 standard deviations above that mean is. So let's just, not a hard problem. Okay, so right here is 20.8, that's the median. Right here is 1 standard deviation, so that's 20.8 plus 5.6 is going to be 26.4. And 2 standard deviations is going to be another 5.6, so that's 31.4, 32, 32.0. Okay, so there's 2 standard deviations, which is 2 z-scores, so that's the answer right there, is 32. 32 or above would admit them to the university. Okay. All right. Last one. On a statistics test, the class mean was 63 and the standard deviation was 7. And for the biology test, the mean score, okay, so we have 2 different means we're having here. The mean score was 23. So let's go ahead and put stat. And here we'll put bio. For bio, the mean was 23. And the standard deviation was 3.9. Determine which test the student had a better score if he received a 73 on the statistics test and a 26 on the bio test. So you're really you're doing the 2 different z-scores for 2 different tests with 2 different means and standard deviations, and you're going to just see which one gives you the higher z-score. So stats is going to look like this. Z-score equals, and so it is 73 on this one minus the mean over the standard deviation. That gives you 1.43. So that's a z-score, so that's 1.43 standard deviations above on stats. And for bio, it's going to be 23. Whoops, I take that back. It's going to be, they got a 26. 26. Minus 23 is the mean, and the standard deviation on that one is 3.9. And that's 0.77. Okay, so that's 1.43 standard deviations above, that's 0.77. That's a higher relative score. So this would be the better score, okay, 1.43. All right, that takes care of that. So I'm going to post this up to 1.04. You'll have the answers to every single question. Your test is a week away, so you got plenty of time to study this, including a weekend. So it's just a matter of will to learn this. It's not that hard. It's probably the easiest math you're going to have this quarter. I'm not going to say everything else is going to be hard, really hard, but you only have this one equation in the whole unit, so it's not that bad. Anyway, so we're going to get started on the next unit, polynomials, here pretty soon. That's going to be look more like math class, and we'll get started on that on Wednesday. Okay, so have a good day.